Sine and cosine. And if you had the tangent of an angle, what did you do to get that ratio? Okay, opposite over adjacent. Same concept is going to happen here with right triangles. We're going to do sine, and that'll be the sin button, or you'll write it like sin, of an angle. And it is going to be the opposite over the hypotenuse. Cosine, written COS, of an angle is going to be adjacent over hypotenuse. We just did sine, cosine, and tangent. And here's how you write SOHCAHTOA. So, ka, toa. So is the sine, and it is opposite over hypotenuse. So, okay, ka, cosine, is adjacent over hypotenuse. Ka. And then toa is tangent equals opposite over adjacent. Start with sine, and let's do the ratio for the sine of A. And again, what is sine? Opposite over hypotenuse. So, taking a look at A, what is it going to be? Opposite over hypotenuse, 15 over 17. Do cosine of A. And what is cosine as far as the sides? Not the numbers, but the sides. Adjacent over hypotenuse. Remember, adjacent is the non-hypotenuse side. So cosine of A would be 8, which is the adjacent side, 17, which is the hypotenuse. What's the tan of A? Opposite over adjacent, 15 over 8. Angle C. And what is the ratio for sine of C? Opposite over hypotenuse, 8 over 17. Find the cosine of C and find the tangent of C. 15 over 17, and the tangent ratio for C? Okay, when I ask for ratio, you've now done them all. We have an angle that we need to find, and we're given two sides. Based on the angle we have, what type of sides do we have compared to that angle? Adjacent and hypotenuse. So which one, sine, cosine, or tangent, are we going to use? We're going to use cosine. So cosine of x equals, what's the ratio? Cosine of x, let's do 10 divided by 27. What do we get? Now we need to undo the cosine. How do you undo the cosine? You do the second cosine, which gives you this cosine negative 1. So if you do cosine negative 1 and plug in your decimal, you will get what x equals. Okay, take a look at the angle that you're given and tell me how those two sides that you're given go with it. They are adjacent hypotenuse, so we're going to use cosine. So cosine 41 equals what? Okay, then hit cosine and put in 41 so you can get the decimal that the cosine is. And what do you get? Equals x over 11. To cross multiply, let's make this a fraction. Then we cross multiply, and we will get x equals your angle. You have opposite. You have hypotenuse. So what's the setup? Alright, what is the sine of 21? And again, if you don't have a scientific calculator, you turn to page 731 in your book, you look for the number 21, you make sure you're in the sine column, and you should have this number as well. Let's make this over 1, cross multiply, and I get x equals, round to the nearest tenth. Okay, and find the x rounded to the nearest tenth. What's x rounded to the nearest tenth? Rounded to the nearest tenth? 5, 8, 7, 8 equals 10 over x. That would be your setup once you plug that in. Then do it over 1, and you'll get x times 0.5878 equals 10. And then you divide. I'm running out of screen. So x equals 17.0. What are we using? Or opposite over hypotenuse, sorry. Opposite. Okay? So sine of x equals what? Okay, so then we have sine of x equals 0.65. Then we have to do that inverse one. We should get rounded to the nearest whole number, 41. How do you do this without a calculator? What you're gonna do is you should be able to get this far. You need something to get this far. But if you don't have a scientific calculator, you can only get that far. What you do is you go, okay, I'm using sine. So I go back to page 731. I look in the sine column for the closest angle to 0.65.